Good morning. Last time we looked at how to determine the ground state term for a D8 atomic orbital. Today, I want us to continue with a D9 atomic orbital. As usual, we begin by writing down the angular orbital quantum number, represented by L, which is 2. Then we write down the magnetic quantum number, represented by ML. Begins from +2, +1, 0, -1, and -2. Because we have the L to be 2, the magnetic quantum number begins from +L, 0, and -L. Since the L is 2, we begin from +2 and then we end with -2. Then the spin quantum number, represented by ms. An electron can spin in upwards way, represented by +half, or in the downward way, represented by -half. Then the next thing is to write down the orbital. The d orbital is a 5 degenerate orbital. So we write down the 5 orbitals. Then the next thing is to indicate the magnetic quantum number. Then since we have 9 electrons, we have to fill the orbitals with the 9 electrons by following the rules in filling orbitals with electrons. So we follow the Hofbauer rule, the Pauli's exclusion rule, and the Hans rule. So we fill with single electrons in the same spin. We have 4 electrons remaining, so we pair up in opposite spin. Then the next thing is to calculate the total orbital angular momentum, represented by ML. To determine the total orbital angular momentum, we need to sum up the magnetic quantum number of the electrons in the orbitals. Considering the first orbital, it has 2 electrons. Since we have the magnetic quantum number to be 2, taking into account the 2 electrons, we have 4 here. Here we have the magnetic quantum number to be 1. Taking into account the 2 electrons, we have 2. Here we have 0. Here we have 2 electrons. The magnetic quantum number is -1. So taking into account the 2 electrons, we have -2. Here we have only 1 electron, so -2. So here we have 6 here. 4 plus 2, 6. -2, we have 4. 4 minus 2, we have 2. Then we determine the total spin angular momentum. To determine the total spin angular momentum, we sum up the spin quantum number of the electrons. Considering the first orbital, this electron is spinning upwards, this is spinning downwards. So the spin quantum number is +half for this and -half for this. So +half minus half is 0. So we can ignore this. Again, we can ignore this. The same thing to this and this. So we only consider this one. Considering this electron, it is spinning upwards. So the spin quantum number is +half. Then the next thing is to determine the spin multiplicity using 2s plus 1, where the s represents the total spin angular momentum, which is half. So we replace the s with half. So 2 cancels 2, we have 1 plus 1, 2. From the previous video, if we have the total angular orbital momentum to be 0, it is s. If it is 1, it is p. If it is 2, it is d. Since we have it to be 2, our term is a d term. And the spin multiplicity is also 2. So you write it here. So the ground state term for D9 atomic orbital is 2D. Thank you very much. Please subscribe to this channel, like and share the video to motivate me to produce more videos like this. Thank you.